Hi everyone, welcome back. In this lesson, we will learn how to solve quadratic equations using the quadratic formula. So, by completing the square for the quadratic equation ax squared plus bx plus c equals 0, you can develop a formula that gives the solutions of any quadratic equation in standard form. So on the slide here shown, quadratic formula, the real solutions of a quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus minus square root of b squared minus 4ac, all that over 2a, where a is not equal to 0 and b squared minus 4ac is greater than or equal to 0. We're going to be using this formula for our next few questions. Solve 2x squared minus 5x plus 3 equals 0 using the quadratic formula. Let's rewrite the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac over 2a. Let's figure out what my a, b, and c are equal to. So my a in this equation is 2. My b is negative 5, and my c is 3. C is a constant, so 3. All we need to do now is to plug in place of where they belong. So x is equal to negative 5. So we have double negatives here. Negative 5 plus minus square root of negative 5 squared, make sure that that's in parentheses, minus 4 times 2 times 3, and all of that over 2 times a, which is 2 times 2. So we have positive 5, negative becomes positive, plus minus square root of 25, minus 4 times 2 times 3 is 24 over 4. And we're just simplifying as we move on. So that equals 5 plus minus, do the roots first, so square root of 1, which is 1, over 4. We're going to end up with two answers, so I'm going to split them. 5 plus 1 over 4, and then I have 5 minus 1 over 4. So the answer would be 6 over 4, which is the same thing as 3 over 2. And then we have 4 over 4, which is 1. So make sure you simplify 6 over 4. So 6 over 4 is equal to 3 over 2. In my opinion, using quadratic formula is the most simplest because all you need to do is just plugging into the formula that's given. And using the quadratic formula will always get you the right answer as long as you don't make calculation mistakes, whereas all the other forms, just like completing the square or using square roots, you will need to make it into the correct format. So I think this is by far the most easiest, and it works for any type of quadratic equation. Next question. The number y of the Northern Rocky Mountain wolf-breathing pairs X years since 1990 can be modeled by the function y equals 0.20x squared plus 1.8x minus 3. When were there about 35 breathing pairs? And it's given you also the graph on your left side. So by looking at this, we need to understand that you're given the quadratic function that represents the number of wolf-breathing pairs for years after 1990. Okay, so you need to use this model to determine where there were 35 wolf-breathing pairs. So let's make a plan to determine when there were 35 wolf-breathing pairs to find x values for which y is equal to 35. That's what I'm writing right now. I'm writing that y is becoming now 35, so 35 equals the rest of your equation given. So in this question, I'm going to move over 35 because I want my quadratic function to equal 0 always. So 0 is equal to 0.20x squared plus 1.8x minus 38. And yes, this equation has a lot of decimals, so therefore you're going to have to use quadratic formula because the numbers are a little bit more complicated to use other methods. So I'm going to rewrite my quadratic formula. And there it is. all I need to do is plug in the correct values and do the math correctly. So that equals negative 1.8 plus minus square root of b is 1.8 again, squared, minus 4 times a is 0.2 times c is negative 38. And all of that over 2 times a, which is 2 times 0.2. That equals negative 1.8 plus minus square root of, if you do the math inside here, it will become 33.64 divided by 0.4. Simplify further, and you get 10 and negative 19 as your final answers. You can ignore the solution x equals negative 19 because negative 19 represents the year 1971, which is not the given time period for this context of the question, so we can reject. And it's also because x represents the number of years since 1990, so x is greater than or equal to 0. That's why we have to reject negative 19 as well. And I circled 2000 because there were about 35 breathing pairs 10 years after 1990, which is 2000. I also want to take a moment here to look at and analyze the given graph. If I go take my point and put a line through 35-ish on my x-axis and all the way to where it intersects the line given, and then I draw a vertical line to your x-axis, then you would get about 10 years, which we got as an answer. That's one way to check your answer as well. And the next way that I want to look at is to use the graphing calculator to find the intersection of this equation in this context. So take out your graphing calculators and insert y equals 35 because I want to find out when it's about 35 breathing pairs. And then the equation given, 0.2x squared plus 1.8x minus 3. It's going to give you a parabola because it's a quadratic function. Then I want to go all the way up to where I can find the 35, the line that has, or where it meets with y equals 35. So what I did is I'm moving it up. So I'm going to zoom out or in. You have to play with it. And then I zoomed out and I went up with the arrow to where, your y equals 35 might lie to find the intersection. So those are my intersections, and I'm interested in only looking at the first quadrant. So I'm going to click second, calc, intersect number 5. First curve is right there, 35, and then the second curve is my quadratic function. Guess, enter again. My intersection is x is equal to 10, and my y is 35. And that's how you would check with your graphing calculators. And this is all for today. Keep up the good work. I'll see you in the next lesson.